New York City, portions of Connecticut, and New Jersey. This may very well be one of the finest secrets in our material science. Betelgeuse, a celestial wonder illuminating the night sky, is a renowned red supergiant star located in the Orion constellation, captivating stargazers for centuries. Recently, updates from notable physicist Michio Kaku have raised alarms suggesting that Betelgeuse may have finally exploded. How this detonation has transformed our understanding of stellar life cycles and the forces shaping our universe is a matter of significant interest. What implications does it hold for us? Stay tuned to discover. Imagine gazing at the night sky and recognizing a brilliant star in the Orion constellation. Betelgeuse, also known as Alpha Orionis, is an enormous celestial body situated at approximately 5 hours 30 minutes right ascension and 0 declination. Its name derives from the Arabic term Yad al-Jawza, meaning the monster's shoulder. In 1603, astronomer Johann Bayer assigned the star its distinguished title Alpha Orionis, indicating its prominence as the brightest star in the Orion constellation. Interestingly, despite being regarded as the most luminous in Orion, Betelgeuse proudly retains its name. Betelgeuse is a colossal star with a mass several times greater than our Sun, rendering it a giant in comparison to our solar system. To put it in context, if the Sun were a small marble, Betelgeuse would be an enormous sphere. Determining Betelgeuse's distance has been challenging, with estimates placing it between 500 and 600 light-years from our Sun, a vast distance in cosmology. In terms of brightness, Betelgeuse glows magnificently with an absolute magnitude of around -6. Harvard University researcher Morgan McLeod noted that Betelgeuse's proximity and size make it one of the few stars scientists can closely study using telescopes on Earth. Images from space telescopes reveal Betelgeuse's distinctive features, showcasing a surface unlike our Sun's smooth facade, rather than a uniform disk of extremely hot plasma. Betelgeuse appears as a collection of irregular, boiling gas pockets, some comparable in size to small stars. Significant eruptions of heated material surge from Betelgeuse's core to the surface, reminiscent of cosmic spring cleaning. One such shell is so immense that traveling at the speed of light would take 75 years to traverse. This process, known as surface mass ejection, expels materials from Betelgeuse's outer layers, akin to the Sun's coronal mass ejections. Despite differing internal structures and mechanisms, Betelgeuse, at a mere 10 million years of age, is remarkably youthful compared to our Sun. Despite its youth, Betelgeuse has already depleted the hydrogen fuel in its core, entering the later stages of its existence as it transitions into the red supergiant phase. During this period, Betelgeuse uses helium to produce carbon through fusion processes, showcasing a rapid transformative journey driven by its significant initial mass upon its formation. Researchers suggest Betelgeuse began its grand voyage as a blue-white type star, belonging to the most massive category of hydrogen-burning main sequence stars. In the realm of stars, size directly correlates with brightness and extreme heat. Larger stars like Betelgeuse shine more brilliantly and burn more intensely. Yet this also leads to quicker hydrogen consumption and an earlier transition to the red giant phase. Betelgeuse's surface reaches astounding temperatures of up to 8,950 degrees Fahrenheit, a stark contrast to our Sun's 10,000 degrees Fahrenheit. As Betelgeuse consumed its hydrogen and began fusing helium, its outer layer expanded significantly, making it possibly one of the largest stars we know, extending over 700 million miles in diameter. By now, Betelgeuse's surface temperature is approximately 5,800 degrees Fahrenheit, cooler than the Sun, yet it outshines the Sun by a notable 7,500 to 14 times. In 1836, astronomer John Herschel observed variations in Betelgeuse's brightness, leading to its classification as a semi-regular variable star with intermittent changes and periodic unpredictable fluctuations, typically following a multi-day cycle. In 2019, Betelgeuse exhibited a peculiarity, deviating from its usual behavior. Betelgeuse's recent prominence garnered attention due to unusual changes. Generally, its luminosity fluctuated following a consistent 400-day cycle, brightening to a magnitude of 1.3 and then dimming to around 2.8. These oscillations were linked to the outer layer known as the photosphere, which emits the majority of the star's light and heat. Convective movement in the photosphere, where heat transfers from the interior to the surface through gases, causes variations in brightness over time. During the autumn of 2019, Betelgeuse experienced significant dimming by approximately 60%, marking a deviation from its standard pattern. The cause was a colossal discharge of material, creating a vast dust cloud that obscured our direct view. Although the dust cloud has dispersed, Betelgeuse hasn't fully returned to its prior state, and its 400-day brightness cycle has shortened to only 200 days. Betelgeuse's unpredictable behavior has sparked discussions about the potential for an imminent supernova explosion. In a supernova, as the star exhausts its remaining fuel, its core collapses, leading to the formation of a black hole while simultaneously ejecting outer layers at speeds of up to 25,000 kilometers per second. If Betelgeuse were to undergo a supernova explosion, it would be a breathtaking display visible for several weeks, much like the full moon, due to its proximity of only 650 light-years. While star explosions are common, they're often too distant to be seen without powerful telescopes, making Betelgeuse's potential supernova a striking event for night sky observers. As stars progress through their life cycles, their cores gather iron, ultimately leading to a supernova. The latest notable supernova, SN 1987A, took place in 1987, approximately 168,000 light-years away. This occurrence was visible to the naked eye and provided valuable insights into stellar development. The last documented supernova prior to this was recorded by Johannes Kepler in 1604, which outshone all other celestial bodies, even during the day, yet had no significant impact on Earth due to its great distance. Betelgeuse, a star currently in the spotlight, is anticipated to undergo a supernova, and Miguel Montargis, an expert on Betelgeuse, predicts its brilliance will rival that of a full moon when the explosion occurs. Imagine a mesmerizing 2-month period where, on a starry night in a darkened city, you could read a book illuminated by the light of Betelgeuse's supernova. In 2021, Betelgeuse experienced a dimming phenomenon similar to the peculiar event in 2019, with a brightness reduction of about 60%, attributed to a cloud within its vicinity. The star's wane disk cloud obscured part of the star, resulting in an absent southern hemisphere in images. After this dimming, Betelgeuse unexpectedly brightened by 50%. The reason for this surge remains uncertain, leading to speculation among astronomers. Currently 15 to 20 times the diameter of the Sun, Betelgeuse falls into the category of stars anticipated to undergo a supernova. Astronomers generally suggest that Betelgeuse could explode within the next 100,000 years. However, a recent study by Hayuki Seo and colleagues from Tohoku University argues it may be closer to an imminent detonation. However, opinions differ regarding the validity of this assertion. Seo's team bases their claim on Betelgeuse's pulsating behavior, which continuously expands and contracts with overlapping signals. While they do not predict an inevitable explosion, they propose it could occur within the next 1,000 years, challenging the longer timeframes previously considered. The uncertainty surrounding Betelgeuse's timeline has intrigued astronomers. However, some researchers contend that stars like Betelgeuse can exist for over 10 million years, a notably brief span for astronomers but surprisingly lengthy for those outside the field. As they search for clues about whether the brilliant star could become a supernova, astronomers note changes in the star's color. In older accounts, individuals describe the star's hue as resembling Saturn's yellowish tone rather than Mars' reddish tint. This raises the question: has the star's color altered? If so, it could indicate rapid evolution, suggesting a supernova could happen sooner than expected. This color transformation provides a hint about the star's changes, assisting researchers in interpreting cosmic events. Whether Betelgeuse detonates on schedule or takes its time to deliver a celestial display, humanity will have a front-row seat to witness the confirmation of extraordinary cosmic phenomena. What might occur if Betelgeuse went supernova? The possibility of a supernova appearing in our sky has captivated people's imaginations. New simulations aid astronomers in understanding what we might witness when Betelgeuse eventually explodes, expected within the next 100,000 years. However, uncertainty remains. Betelgeuse is approximately 500 light-years away, and recent studies indicate a significant star must be within about 150 light-years to cause noticeable effects. About 26 million years ago, an event of this nature may have contributed to a mass extinction affecting marine life after the Permian extinction. If a supernova were to happen in our vicinity, closer than 30 light-years, the implications could be uncertain. Although Betelgeuse's supernova is not expected to pose a threat to life on Earth, there could still be some atmospheric effects. The explosion would produce a surge of ultraviolet radiation, potentially causing a temporary decrease in the ozone layer. Cosmic rays emitted from the explosion would likely be minor and brief, with limited ecological consequences. Shortly after the explosion, we would detect weightless particles known as neutrinos, which are harmless to us. The star would quickly become more luminous, achieving brightness comparable to the full moon within weeks. Betelgeuse's brightness would then diminish over time, illuminating our daytime hours for approximately 6 months to a year. As night falls, it would remain a prominent feature for another 1 to 2 years before fading away. Tragically, Orion would lose its signature red glow, a shimmer forever remembered. Regarding potential threats to humanity, supernovae emit powerful particles called cosmic rays, which can penetrate Earth's magnetic shield. However, aside from the nearest supernova, the amounts would generally be negligible compared to other radiation we encounter. The supernova's breathtaking finale wouldn't just astonish us, it would also generate radioactive iron, an immense signature found in Earth's ocean floor and even on the moon. This iron, produced from a supernova that occurred 2 to 3 million years ago, was merely 300 light-years away from us. Fortunately, its proximity posed no significant risk to life on Earth. Rest assured, such a nearby cosmic explosion is an extraordinary event, potentially happening only once in a billion years. As speculation surrounds the potential spectacle of a Betelgeuse supernova, space expert Andy Howell from the University of California sought more than just rough estimates. Pursuing precision, he enlisted the assistance of 2 former graduate students, Jared Goldberg and Evan Grove. Their detailed simulations vividly illustrate the star's epic conclusion, acknowledging uncertainties while leveraging insights from observations of supernova SN 1987 at the closest recorded instance of a star's catastrophic end in modern times. These astronomers concluded that life on Earth would remain unharmed. However, the astronomical landscape would not stay unchanged. According to Goldberg and Grove's findings, when Betelgeuse ignites, its brightness will resemble the gentle glow of a half-moon, shining about 6 times dimmer than the brightness of a full moon. This captivating illumination is projected to grace the skies for over 90 days. Recent studies suggest that Betelgeuse is around 724 light-years away from us, safely beyond the anticipated risk zone. Nonetheless, the supernova could have intriguing implications for Earth. Howell emphasizes that many creatures rely on the moon for navigation and might be confused by additional bright objects. Astronomers themselves would face challenges, as the intense brightness would exceed the capacities of telescopes and space observatories. To adapt, telescopes would need to capture the subtler, gentler illumination. Experts reassure the public that there will be ample warning if Betelgeuse detonates during our lifetimes. Instruments on Earth would detect signals such as neutrinos or gravitational waves generated by the explosion, providing advance notice as much as a day before the event. While this occurrence is unlikely to happen for another 100,000 years, Betelgeuse will ultimately transform into a supernova, and the aftermath depends on the materials that remain following the grand finale. We continue to anticipate Betelgeuse's potential supernova as researchers refine their predictions and enhance their understanding of such cosmic phenomena. Observations of comparable stars at various stages of their development yield crucial data from modeling the life cycles and possible explosive endings of massive stars. This information assists astronomers in evaluating the frequency and impact of supernovae within our universe, contributing to our broader comprehension of cosmic events and their ramifications for both nearby and distant celestial bodies. The study of Betelgeuse and other supergiants also aids in calibrating cosmic distance scales. Accurate measurements of such stars' brightness and behavior help improve the methods used to determine distances to far-off worlds, thus refining our overall mapping of the universe. Furthermore, supernovae serve as invaluable probes for understanding the synthesis and distribution of heavy elements like iron and nickel throughout the cosmos. These elements play a crucial role in the formation of planets and life as we know it. In the meantime, space observatories are closely monitoring Betelgeuse and similar stars, utilizing cutting-edge technology to detect any signs of impending change. These efforts ensure that we are prepared to observe and study one of the most dramatic events in the universe's life cycle, enriching our understanding of the dynamic processes that shape the cosmos.